My name is Dayana Nogovitsyna. I am a student of 10th grade of Northeastern Federal University, let's say, and also I am a member of Sakha Junior Academy, and today I want to present you my project, Mathematical Methods in the Study of Traffic Flow in the City of Yakutsk. One of the leading places in urban air pollution is motor vehicles. A significant part of emissions occurs in traffic jams and in front of traffic lights. This project considers SJSA.RU of the traffic lights mode and traffic capacity at crossroads of our city. Due to the growing number of cars in Yakutsk, this topic is relevant. The goal of this project is to study the mode of operation of traffic lights and traffic capacity at the crossroads of the city of Yakutsk to check the likelihood of traffic jams. To achieve this goal, we set these tasks: to choose the busiest crossroads in Yakutsk, to measure the specific parameters, to substitute the obtained data in the formulas, and to make conclusions. Also, we've suggested the measures that can improve the situation. In 1955, the following problem was posed and solved from the Leahy-Wissam-Richards model. To calculate a value k such that when the condition T green divided on T red is more than k fulfilled, the q under the traffic light will not accumulate. The traffic flow away from the traffic light has a density qy is lesser than qm, where qm is a density with the maximum flow value. We need to find the value k, which is qy divided on qm minus qy. In this project, we use the above formulas in the conditions of the city of Yakutsk at individual crossroads. The operability of the formulas on real-world data has been tested. The study was conducted in winter, December, and summer, July-August time. On working days during rush hour, it's from 6 p.m. to 7 p.m., as well as on Sunday afternoon, 3 p.m. to 4 p.m. For the study, crossroads and road sections of the city of Yakutsk were selected, where traffic jams are most likely to form. We also used formulas from the queuing theory for a single-channel system with a limited queue length. We measured the intensity of the incoming and outgoing traffic flow per minute, the driving time of the entire section in free flow without congestion, and also calculated the maximum number of cars that fit on this section. The conclusions are these. Measurements and observations confirm that the most difficult traffic jams conditions are observed in the summer during rush hours. Improving the traffic situation in the city center during the rush hour in both summer is possible only with additional construction of roads or a decrease in traffic flow, and the traffic light mode cannot help here.